Automotive applications these days requires a lot of AI, and simulating that is going to be a very important way of making things work, especially right out of the box. Unfortunately, there are obstacles in the way, but a lot of innovation that's going on. So, Seth, given the inherent complexity in developing and delivering a complete AI solution, how do engineers lay the groundwork for pulling all this together? For example, how do they understand what the steps are and where should they be starting?
Yeah, that's a great question, Bill. So, the thing I like to point folks to for starting is certainly training. There's a lot of training options out there available. You can learn about machine learning or deep learning technologies. You can learn about what it takes to integrate these tools into more engineering workflows. And so I think having training, having some kind of fundamental understanding of how do the AI models work, just getting your hands on them, that can be incredibly valuable. And we've been focusing on, at MathWorks on everything from short 2 hour in your web browser, kind of, play around with it, to in-person trainings, and even like MOOCs, massively open online courses on Coursera. So I think there's definitely a variety of different options depending on how, if you just want to dip your toe in the water or if you want to dive right in. The other thing that I would say is really valuable for just kind of pulling it all together and understanding the space is examples. And so it used to be in the AI space, like I can remember not that long ago, where all the examples were images of cats and dogs, and it's like you're building a classifier that tells you whether the image is of a cat or a dog. And while that was, I guess, interesting and fun to work on at the beginning, it was a big leap to get from that to how do I apply this in a type of engineering application. Nowadays, it's very easy to go online and search for examples and find things that are much more in engineers' domains. So you can find like an example of AI being applied as like a reduced order model for an ICE powertrain or an electric powertrain or things like that. And so being able to start with those examples that are in the domain is I think really key to enabling folks to get started in this space.
Oh, very good. Well, speaking of examples, could you talk a little bit about what some of the automotive applications that would benefit most from this type of simulation?
Yeah, so I mean, I think, in general in the simulation space, we definitely see this push to have more and more of the vehicle and the environment around it in the simulation. So what folks are trying to incorporate in the simulation definitely seems to be growing and growing. When it comes to like the combination of AI with simulation, one place where I always like to look for potential projects is in systems where the physics are very complicated, or they're not that well understood. So you can think about things like combustion or after treatment, things that involve chemistry and lots of chemistry going on. And
Hmm.
it's, we have approximations for what's going on there, but you're never going to model everything perfectly. Those can be examples of places where, maybe taking like a reduced order model type of an approach, approximating that rather than doing a first principles physics approach. You could kind of use AI in that way, and that could be a good potential there. We also see a lot of interest when there's opportunities for like virtual sensing types of applications. So this is where you might have you know quantities that you can observe in your simulation, but it's expensive, or to put a sensor there in production, or it's too costly. Whenever folks are looking at how do I reduce the number of sensors in a system, or can I estimate the state from other things, maybe not using like a traditional linear approach, but using more of an AI, a nonlinear model approach, that can be another really interesting application for AI. Of course, automated driving is definitely an area as well. We see there, it's a combination of both scenario generation. So how do I generate all of these, computerized scenarios to run my automated driving models on? But then simulation is definitely key for automated driving, for iterating on these AI algorithms in these vehicles, improving them, understanding their strengths and weaknesses before you begin to test them in the real world. So lots of different applications.
Okay, so what does the future hold for AI simulation in automotive applications? Are we going to be seeing some new areas of advancement?
Yeah, so I think the story here is really there's going to be a lot of streamlining of the workflows for bringing AI into automotive systems development. Right now the AI space is a bit, there's lots of different models, types of models, there's lots of different frameworks, and so we've had a focus on how do you import models from all these different places into into Simulink for simulation and actually kind of go on with the embedded systems development and Simulink. So being able to work with all those different frameworks and models is definitely, I think, a key thing. One of the trends we're seeing, interestingly enough, is a trend towards smaller models. There's definitely trends towards larger models in certain areas of the AI space. But for automotive systems, there's always going to be, this trade-off, and where, larger models equals more RAM or more cost on the hardware on the vehicle, especially if you're running it locally. And so, we continue to see a lot of folks looking at, well, could I, instead of maybe using a really deep neural network, could I get similar results out of maybe some smaller model, maybe either a smaller neural network or even some traditional machine learning types of approaches? Related to that, we've got a lot of kind of interest in quantization in these types of techniques that can quantize an existing AI model that's been shown to have good performance, and you quantize it, you can reduce the memory footprint of the model that way, validate that it's still performing to your requirements, and then that's another way to kind of reduce the footprint of that model. So continuing to kind of make these models smaller so that they can more cost effectively be integrated onto the vehicle. We talked a little bit about reduced order modeling and that kind of notion earlier. I think we're going to continue to see more integration of physics and AI models. So there's things going on right now, such as physics-informed neural networks, where you're trying to bring in some of the physics into the AI model. You still have some non-parametric, kind of neural net types of features in that model, but you also bring in some physics so that you have a little bit of kind of first principles understanding incorporated in there, combined with some AI model that can approximate the rest of the system. And I think that's going to be another place where we continue to see a lot of interest, just because of it, it kind of helps you around some of the issues associated with black box AI models, and kind of you do want to have some of that knowledge of physics in the model in many places. And then as we talk about bringing this all to production, there's a lot going on in the verification and validation space right now in terms of how do you do verification and validation for AI. There's a lot of industry groups out there that are looking at this. How do the existing processes need to adapt for AI models? They work right now for traditional software development, but in terms of how those apply to AI, that's there's lots of work going into that right now. And we're working with those standards bodies and kind of helping kind of evolve those standards so that we can ensure that we are delivering AI models in a way that's up to our standards for running in these safety critical systems.
Well, as we wrap up this video series, are there any topics related to the future of AI simulation in automotive that you'd like to cover before we close?
No, nothing else I can think of, Bill. I think it's just, there's a lot going on in this space. We've discussed a lot, and yeah, thank you for having me on. I've really appreciated it.
Great. Well, thank you very much.
Yeah, thank you.